going to set up our premise here. There's a child on a swing. The child's only on the swing for 30 seconds, which is an eternity for a child right here. All right? I'm going to give you 4 descriptions of functions and 4 graphs. Your job is to do 2 things. You're going to match functions as descriptions to their graph, and then you're going to label the x and y axis of all the graphs. So you're going to have to sketch these 4 graphs in your notebook right now when you see them, okay? So again, child on a swing, 30 seconds. Time is always the input. You're going to match the situation to the graph and label the x and y axis. So here's your function h, r, d, and s. Each one of those is going to match one of our functions as a graph, and then you're going to label the x and y axis of each one. So you're going to need to sketch all 4 of these in your notes. Let's go. Looking at function, well, let's say graph A. Who's got the function that matches A for us? Which one do you think matches, Emmett?
So you're asking for...
Which function matches A?
A would be R.
Yeah, I got function R for A, which would mean, what would our x and y measurements be? Our x-axis would be what unit?
Time.
Time, and what would our y-axis be?
Time. So
Yeah.
Time is a function of time.
Yep. Time left goes down as time increases.
Yep.
All right, graph B. Raymer, which one are you thinking for graph B?
Function S.
You think it's S?
Yeah.
And it's pushes, right?
Yeah.
So what is my x-axis?
Time.
And what's my y-axis?
Pushes.
Yeah, pushes. And the reason it looks like this is each push, you're not increasing the number of pushes, but that one push happens for a period of time. Why do you think they're getting longer and longer?
It goes higher and higher.
Yeah, when they're higher, you don't have to push as often. Okay. C, graph C, which one does that match, Will?
Graph C matches D.
Yeah, it matches D. So this is time. And what's the y-axis?
It's the distance from the top beam.
Distance from the beam. That's the y-axis. Yeah, unless you're a real OG like me and you try to get as high as you can, you hit that little bit of slack maybe.
Yeah.
But this one's not hitting the slack. This one's just hanging. It's the same radius over and over, okay? And then D must be what then? It has to be H. It's the only one left. And this is how it's going up and down, up and down. So time is still along my x-axis. What is my y-axis?
Height of swing.
Yeah, height. Okay. So there it is. So we're going to need to know these because what we're going to work on next is coming up with the domain and range of these different things. So to recall from yesterday, what is the domain? Micah?
Amount of inputs.
Not the amount,
The range of the inputs.
the set of the possible amounts of input, the possible inputs. And so what is the range? All the possible outputs. So as we're looking at domain and range, we're going to be looking at different units here. Now this is going to get a little messy for the presentation and how to... I kind of want to look at these and the next slide at the same time, but there's no way to look at 2 slides at once. So we're going to be flipping back and forth. We're going to lose our labels first, which is fine. So here, we're just going to look at the top bullet first. Here's some information we're given. The child is given 30 seconds on the swing. Okay? So what I want you all to do here is give a domain and a range. And so I'm going to put it in brackets because it's like a set. And we all know, I'm not good at brackets. You can't be good at everything. So you're to come up with a domain and range. They're on for 30 seconds. And domain means what are all the possible inputs, what are all the possible outputs, and we're only focused on this one right here, the swinging for 30 seconds. So you and your partner come up with a set of all possible inputs and all possible outputs. Who's got potential inputs for me? What are the potential inputs, Tess?
1, 2, 3.
Okay, what about 0 time?
Oh yeah, you can.
So 0 would be the lowest, and I'm going to write like this. My inputs are x. It needs to be greater than or equal to 0, but less than or equal to 30. And do fractions, decimals, everything work for time? Can I have 10 and 1/4 seconds? Yes, okay. What about the range? The range in this case is also time. Yeah, Nancy? Yeah, so I'm going to write it this way with the inequality. You could write the words, all values between 0 and 30. I like this way. It's just concise. I don't have to write words. And this is how you'll see it pretty often, actually. Well,
For the range, since it would be decreasing instead of increasing.
yeah.
1 second, I would switch I would just drop the
Well, it's just all possible inputs, so it's usually just low to high no matter what. Right? Because for answering the question, all possible outputs, it doesn't care about like what happened in time. It's just like these are Yep. Raymond.
So you can put the inequalities on that because then it means less than or equal to 0.
No, y is greater than or equal to 0.
Oh.
And y is less than or equal to 30. Yep. Great. So let's work on the next one. So the next piece of information, the adult pushes the swing a total of 5 times. Oops. So we go back here. That means we're looking at which one? B. Okay. And that means right here, that's 5 pushes, right? So I want a domain and range for this. All possible inputs, all possible outputs.
How do you mathematically say integers 1 through 5?
You could just say it with those words. Hey, my left brackets were okay-ish. Let's go. Okay, so I'm going to take the hard one. We're still rocking 0 to 30 seconds here on the domain. Okay? Who's got the range for me? Emmett?
0 through 5.
So we could say 0 through 5, and then we need to state whole numbers.
Yeah.
Because we don't have fractions of pushes and stuff, right? I heard the word out there, integers. Integers kind of wouldn't be wrong if you said 0 through 5. The definition for an integer is whole numbers and their opposites, which would be like 1, -1, 2, -2, 3. Those are all integers. But if you said integers 0 through 5, the only integers for 0 through 5 are 0, 1, 2, 3, 4, 5. You could also list 0 through 5. The 0, 1, 2, 3, 4, 5. That would also work. Okay? Cool. I think you guys are getting the hang of
Wait,
it.
couldn't you write x is equal to or is greater than or equal to 0 and then x
Less than or equal to 5, but then also state it has to be whole numbers.
Right.
Yeah. So let's look what next. The swing is 1.5 feet above the ground, and the highest point is 4. So we're going to use that 1.5 feet above the ground, and the highest is 4. We're going to jump down here. Oopsie. 1 sec. Nope. I hit some stuff. Here we go. That means right here we're 1.5 off the ground, and the highest it goes is 4. So I want the domain. I'll take care of the hard part for you guys. Okay. Domain 0 to 30 seconds. Okay. You guys are gonna focus on the range for me. Let's go. All right. Who's got a range for me? Finn.
1.5 to 4.
And does everything in between work?
Yes.
It does. You can have all kinds of fractions and decimals of heights. Excellent. We good? Everybody's got that down? Last one more. The top beam is 7 feet away. So, what is this value? 7. I'm going to take the hard one. The domain is 0 to 30 seconds. Who can give me the range?
7.
Everybody?
7.
Yeah, you just say y equals 7 for the range.
Wait, 8 favorite number.
Okay? It's just always 7. The output's always 7. Is that a function?
Yes.
Let's check it out. Does each domain have a range?
7.
Vertical line test. It works. These are all functions, friends. Sweet. So this is going to look familiar. Have you guys seen a bouncy ball before on something?
Yeah.
Maybe your test that you just took recently? Yep. So you're going to answer the 4 questions associated with the bouncy ball. You're going to give me the output when the input is 0, the input when the output's 0. You have to describe the domain and describe the range. I think 3 to 5 minutes with your partner, we can get her done. Okay, if 0 comes in, what comes out?
6.
6. It's right here. When 0 goes in, 6 comes out. To get an output of 0, what would x have to equal?
0.5, 1.5, 2.25, 3.75. 1.54.
I'm going to say 3.78. It looks like a little more than 3.75. Okay, so let's talk about the domain. Remember, the domain is all possible inputs. So I like to set this one up like this. It's not every time, but when it's like a lot of different answers, infinite answers, it looks like this. What's the lowest it could go?
0.
And then what's the highest it could go?
3.78.
I got 3.78.
Okay.
Or, maybe there's more bounces happening. You could also write something like when stops bouncing or something. Because it looks like maybe this graph, maybe it's not done there. Maybe it bounced again. Okay, the range. All possible outputs. What's the lowest it can go?
0.
What's the highest it can go? Can it go everything in between? Yeah, this isn't a teleporting bouncy ball, which would be kind of cool. Unless you're like playing catch and all of a sudden it's like, in your face. Yeah. All right. Let's go over the summary together and then you're going to do the cool down. So the summary together, does 100 fit in this range? Does 0 fit in the range? Really?
No.
There's no output of 0 anywhere. So nope. So the range, what's the lowest it goes?
10.
What's the highest it goes?
75.
I got 75-ish.
I got 70.
Does everything in between work? Yes, because this is continuous, everything between works. Back to your assigned seat for the pot of water problem, baby. Let's go.